Okay, this recording is to cover the exercises in lecture 12. Slide 23 is the first. Okay, so I'll start on slide 23. Number 1, it is a large sample with a strong effect. Therefore, it is yes, significant. Okay, so number 2 is a small sample with a small effect. Therefore, it is unlikely to be significant. I would answer no for that one. And you can figure the small effect size, calculate D, by dividing uh, the difference, which is 1. So 25 minus 24 is 1. And divide that by the standard deviation of 5. That gives you 1 divided by 5 is 0.2, and 0.2 is a small effect size. Number 3 is a medium-large sample and a medium-size effect, so it is, yes, likely to be significant. Next slide, slide 24. The first item is missing a sample size, so the answer is it's not possible to answer that question. Not enough information. It's a small effect, but an unknown sample size. Number 2 is considered a small to medium-sized effect, sample, and a weak effect. So we would say, no, it's not likely to be significant. Number 3 is a medium-large sample with a weak effect. We would say, no, that is unlikely to be a significant finding. And number 4 is a small-medium sample and a medium effect. And we would say, probably no, probably not significant. Okay, so those are the answers that I came up with. I hope that you were able to match them to your own answers and find yourself right. Next, we go to slide 25. First one is a very hard problem. It is to conduct a conduct a one sample t-test. So I didn't give you enough information to do this, so I'm going to provide it to you now. You can use an online t-test calculator. I have now provided the link to one on the slides. So if you click on that link and go down about halfway down the page to the second panel, you can enter in all of the details that are required for conducting the t-test, and all the information is provided there in the problem on this slide. So using that method, you would conduct the one sample, two-tailed. The reason you're going to do a two-tailed and not a one-tailed is because we don't have any real strong theory about why it has to be only a one direction effect. We can't judge the direction by looking at the data. That's not allowed. So we're going to use a two-tailed test. And remember that you're almost always going to be using two-tailed tests when you're doing t-tests. Okay? So the sample size is 25. So plug that in. Or if it asks for degrees of freedom, you just subtract 1, so 24. The mean, 5.3. Population mean, 4.0. Standard deviation, 1.5. Now, depending on which website you go to, you might need to calculate the t-value by hand first, because it might just ask you to enter the t-value in order to calculate the significance. So if you were going to calculate the t-value by hand, you could do that based on the information given in this problem. It's not too easy unless you're good at math, but the formula for the t-test is given on slide 8. I said it's not too easy. Really, it's not too hard. It's basic arithmetic. So what I did was 5.3 minus 4 to get a difference between the one sample and the population. So that's on the numerator. That's calculates to 1.3 on the numerator. On the denominator, you've got your standard deviation of 1.5 divided by the square root of the sample size, or the square root of the degrees of freedom. So it's the square root of 24. Or you could do square root of 25, either way. So if you're doing 25, then it's neat and easy. It's 5. The square root of 25 is 5. And then you do 1.5 divided by 5 to get your next number, which is the denominator. Anyway, when you do all of that math, you come out with the t-value of, it should be 4.333 repeating. If you're doing quick and easy math, or if you did the degrees of freedom of 24 instead of 25, then you might come up with a different number. Looks like I got 3.67. I might have made a miscalculation. Anyway, whether the t is 3.6 or 4.3, either way, it's definitely a significant finding. So this one is significant because the p-value is far lower than 0.05, the traditional cutoff. Okay. Number 2 on this slide. If p is 0.02, describe the significance in terms of null hypothesis testing. I just gave a super simple, easy answer. It's this. You can compare it to your own answer that you offered. My answer is P of 0.02 means there's a 2% chance that the null hypothesis is correct. All right, so I guess another possible answer would be that there's a 98% that the null hypothesis is not correct. Or, yeah, I think that's pretty much it. You have to answer in terms of the null hypothesis, because the t-test and the p-value, well, okay, the p-value is always in terms of the null hypothesis, and it is the probability that the null hypothesis is correct. So you can call it a 2% chance. All right, next. Maybe that's it. Yeah, that's it. Okay, so the next slide, slide 26, offers you formulas for calculating the R statistic, the Pearson's R, if you're doing a correlation study, or the t-tests, if you're running a t-test, like comparing two groups to each other, or two conditions to each other, if you're doing a dependent measures design. Anyway, if you have any uncertainties or questions about how to analyze your data, please email me and describe as much as you can about your study design so that I can help you as best I can. All right. Next Tuesday is our test, and a week from then, your paper is due, and a week from then, your presentation, as I described in lecture 12, I think. All right. Good luck. Bye.